So what we have to do today is that plug right there, they need to be closer over here. They've got this light, I guess. Actually, no, this is a boat lift, but they do have an underwater light that they want to be able to plug in up here somewhere, and it just won't reach. So they don't really use this plug. So what I got to do is just take that off that junction box up there. Need to fix this. This is falling off. But yeah, just remove that. Put this guy on that pole. Just rerun some flex. I brought 100 feet of car flex and put another box here. Pretty simple stuff. So for this job, I'm not wearing 80 pounds of tools. I'm not going to be wearing a tool belt like I normally would. I'm doing very specific kind of simple things. So I keep on me a multi screwdriver, a set of lineman's pliers, and a needle nose that has strippers on them. And I also keep with me an impact drill. Everything else, I just keep a carry bag nearby, so I have a whole bunch of extra tools if I need channel locks or like knives or just anything kind of specialized. I keep this thing nearby so I don't have to carry all these tools on me. One challenge that really made this job a struggle was making sure that I had everything down there with me. So if you look on the drone footage, you can see that there's a lift that goes about like a mile a year. So you have to drag everything down this long winding driveway just to get into the backyard to jump in this lift and just sit and go all the way down to the lake. And it's far, you know, it's like, I don't know, probably a couple 100 yards. So once you get everything down there, you don't want to have to go back up into the truck and get some stuff. I did a couple of times, like I couldn't carry everything in one trip. I had all of my tools and everything. I had my ladder, took all that down, went back up to the truck, got a bunch of screws and stuff like that. But then like, I forgot like a strap. Dude, I was so pissed to have to go all the way back up that fucking lift just for one strap. So it was kind of like a unique job in that fact where it was like, I need to remember every single thing because this sucks. All right, big shout out to Ariat. Thank you guys so much for sending me some boots. I've been rocking a little bit different boots than I normally do, just trying to get used to some different styles. Y'all know me by now. I love Ariat boots. If you're in the market for new boots, I recommend Ariats. They're gonna last you a long time. Usually I get about 2 to 3 years out of a really good, you know, $200 set of boots. But if you wanna get some Ariats, there's a link in the description below. It kind of shows my favorites, and there's even a discount code. All right, the first thing that we are going to do is disconnect power. Every job that we do, we need to disconnect power so we're not working on anything live if we don't need to be. First thing I do is I disconnect the wires that are up in the junction box, up in the canopy of this boat dock. I have to do this very carefully so I don't drop the screws or any of my tools. But then I need to remove the car flex and move the existing box that has the receptacle in it. Next thing I do is I take off the straps that are holding the existing car flex to the steel. It helps to have an impact driver to do this because you're talking about like rusted out, you know, like steel that's got screws in it. So just having an impact that can kind of break those screws loose a little bit, it just seems to really help. That's kind of crazy. I mean, I didn't do it, but makes me want to fix it. Let me know in the comments. Would you fix that, or would you just leave it?
Next thing I do is take off all the straps that are holding the existing car flex to the steel. Then I remove the existing receptacle and bell box.
Now, fun fact, did you know that it's called a bell box because of the company that used to make the first ever weatherproof boxes and covers? They had this company named Bell. They started creating boxes. They're called Bell boxes. So a bunch of old timers call them Bell boxes. Not everybody does. But then they were bought out by Square D after a long time, and then they were bought out by Rayco or Hubble. Rayco is kind of the same company. But there's your fun fact for the day. To secure a bell box, a lot of people like to try to drill holes in the actual back of the bell box. I don't recommend doing this. It will work. Yes, you can knock some holes in the back of it and screw right directly to something. So it has a nice flush look. There's no extra tabs hanging out. But when you do this, you actually lose the weatherproof nature of the box. So these boxes have these little knockout seals that you screw in place. They can have 3 of them, 4 of them, 5 of them. There's a whole bunch of different ways that bell boxes are configured, but they come with these little metal tabs, and these tabs go on the back side, and it's what you're supposed to use to secure the box down. And a lot of people just don't like to use them because they think they look ugly or whatever, but I want to keep this box weatherproof. It is definitely in a weatherproof environment where moisture is going to be a problem, so I'm not going to be knocking any holes in the back of this box. Next, I screw the bell box to the pole, and I use self-drilling screws. A lot of people call these self-tappers. They're not actually self-tapping screws. There's a difference between a self-drilling screw and a self-tapping screw. I have called self-drilling screws self-tappers for so many years. It's actually wrong. Tapping is threading a hole. So there are screws that are meant to be drilled so that when you're finished drilling, you actually have a threaded hole that you can stick a machine screw in. Whereas self-drilling is what we are using to drill a hole, and then once the hole is popped, the screw will actually sink into that hole. So I'm using self-drilling screws and my impact driver to get that box in place. The next thing that I do is I measure out a whole run of 1/2-inch Carflex to fit the full run, and I think the easiest thing to do is to pull wire in first. It is so incredibly difficult to try to push wire into a whole, like coiled up, curled up mess of Carflex. Same thing for metal flex or seal tight. Seal tight is liquid tight metal flex. So it's kind of like Carflex with metal, flex on the inside of it. But either way, you're not going to be able to push that in unless you get the thing straightened out. So a pro tip that I recommend, obviously, ideally you're gonna wanna have 2 people do this. Like, I'm probably dealing with 50 feet of Carflex right now, and I'm down there by myself. I don't have somebody to help me hold the Carflex straight, and I don't have any, well, I do have fish tape, but it's not gonna be possible for me to try to run a fish tape in one end and hook it up and then try to go to the other side unless I can get this thing straightened out. So my pro tip is using a ladder, using posts or anything that you've got available. You need to get that Carflex taut. Again, this can be seal tight, metal flex, any kind of flexible conduit, but if you can get pulled really tight and in a straight line, you'll have an easy time just pushing your wires all the way through to the end of it. And that's the only way you're gonna get the wires all the way through to the end of it, unless you do get it all taut and you get it secured in place somewhere and you can run a fish tape through it and then go to the other end and like hook up your wires. But then you got to go back to the other end and try to start pulling on your fish tape, and the chances of the wires getting all messed up and knotted and you having to run back and forth, it just sucks. So I find it easier to get everything pulled really taut in a straight line and then feed from this side, wherever your wire is, feed from that side and just push it the entire length of the way. Now, once I have the wire in the Carflex, I secure one end of the Carflex to the box, so that way I can start strapping the Carflex in place, and then, as I go, I start removing all the slack, making sure that it's really neatly strapped. I did go back and secure that other piece of Carflex that whoever Mr. Lazy Guy Electrician did not do last time. You're already there, so that's my whole thing. If I'm already there and something's shitty, like, why not fix it? If it's literally I'm just putting 2 straps up, like, why not fix it? Why not make everything when you go into an environment better than it was when you got there? Then once I get the Carflex all strapped out and to the other end of the box, I measure and cut that Carflex. I'm being very careful not to cut into any of the conductors, but you cut it to make it to length, and then you stick it in the box. Then once I have the conductors in the box, I actually measure each one out and twist joints and get everything hooked back up in the box, and then close the box up. Now that I have the beginning side of that circuit taken care of, I just need to go back to the end where I put the new bell box and put a new receptacle in. I am putting in a WRTR receptacle that is a weather resistant, tamper resistant receptacle. Code time. Now, if you notice, the receptacle that I'm about to put in is a WRTR receptacle, which means that it is weather resistant and tamper resistant. So per code, if we open up our handy dandy code book and we go to receptacles, which would be 406, receptacles, cord connectors, and attachment plugs. In 406, you're going to find a reference 406.4D6. where it says weather resistant receptacles. Weather resistant receptacles shall be provided where replacements are made at receptacle outlets that are required to be so protected elsewhere in this code. So as code likes to do, directs you from one place in the code to another place in code to find the information rather than just giving it to you. So if we move forward a little bit in the same article, we have 406.9 receptacles in damp or wet locations. Now, it's up in the air a little bit whether or not we're in a wet or a dampened location. I say we're in both. You know, we're out on a boat dock, so like waves coming in, if like boats drive by, it could splash and get all over the place. Typically though, that's probably not gonna happen in a damp location. Anything that has an awning that's underneath an awning that's not gonna be directly rained on is essentially a damp location. But anything that, you know, could have like rain beating on it, water beating on it is considered a wet location. So it's arguable at least that this plug could be in both. If we look at the definitions in 406.9A under damp locations, the third paragraph says, a receptacle shall be considered in a location protected from the weather, where located under roofed open porches, canopies, marquees, and the like, and will not be subject to beating rain or water runoff. That is what they consider a damp location. Now, a wet location, they don't actually give you a proper definition, but they do talk about it being weatherproof. So in wet locations under 406.9B, it says receptacles of 15 and 20 amp, 125 and 250 volts installed in a wet location shall have an enclosure that is weatherproof, whether or not the attachment cap is inserted. So if we go back to the beginning of the book in Article 100, there are definitions for weatherproof and I believe watertight. Weatherproof, it says in 100, constructed or protected so that exposure to the weather will not interfere with the successful operation. So again, it's kind of arguable either way, but I'm using a WRTR because either way, this is a wet and a damp location. That is what I'm considering this environment. Now the other part of that, I said it was a WRTR receptacle. The TR is for tamper resistant. Tamper resistant receptacles are covered in 406.12. It says all 15 and 20 amp, 125 and 250 volt non-locking type receptacles in the areas specified in 1 through 8 of 406.12 shall be listed tamper resistant. It says dwelling units, including attached and detached garages and accessory buildings. 2 dwelling units and common areas of multifamily dwellings. So this is kind of an accessory building to a dwelling unit. So I'm using a TR receptacle for this building. All right, last thing that I do is I close up the box, turn power on, and then I take my plug tester and go over and test the plug, make sure everything works. If you don't have a plug tester, you should have a plug tester. I specifically use the GFCI plug tester. That way you can trip any plugs that are on a GFCI circuit and just make sure that the actual GFCI device works. The one thing that you don't see on this footage is that this circuit is GFCI protected, but it's inside of the dock storage room. There's a GFCI in there that controls all of the receptacles that are on this dock. Now, it's really important to make sure that you have GFCI receptacles because people can get electrocuted, especially around water. So there's everything in the code book. There's tons of references anytime they're around water, in homes, bathrooms, outdoors, garages, all kinds of places that you can read more in 210 about that. But just make sure that if you're doing something on a boat dock like this, that you make sure that there is a GFCI in the dock, and make sure that you test the GFCI circuit to make sure that it works. Because if somebody's standing in a pool of water and they go and touch something that's metal, and for some reason a wire came disconnected and it's live and it's touching that metal, and you don't have any sort of GFCI protection, that person can get electrocuted very, very badly, a lot more because of the moisture, the wet environment, than they would if they were dry. So when you're wet, you offer a lot less resistance for current. Now, the less resistance that you offer, the more current can go through you. So it's actually a lot more dangerous situation to be wet or to be standing in water when a ground fault happens if you don't have proper ground fault protection. So a GFCI device is meant to be able to detect a ground fault and immediately trip within a fraction of a second from a very, very low threshold of current. All right, and the last thing that I do is I remove that old flip cover, the old weatherproof cover on that existing receptacle. I put a new in-use cover in on both of these receptacles. I think this is a very wet environment, and they are going to be plugging in lights. They're going to be plugging in all kinds of stuff out there, and probably leaving it plugged in and just the water splashing around and everything. Just a very damp environment. So I make sure to put the new bubble cover on, or the new in-use cover, and that is it. So leave some comments below. Let me know if you guys would have done some things differently. Let me know if you would have taken care of that unsecured car flex, or if you would have just left it for the next guy. Thank you guys so much for watching. If you haven't yet, please join the channel membership. Super helps me out. You get little tidbits of extra things throughout the week. I like to put little posts about tools and about like opinions for next videos that I'm doing. The 480 volt members, you actually get your name on the screen, like all of these guys right here. Oh, these are my homies. Thank you guys so much for all of the support. You keep me going, and I really appreciate it. So make sure you like, make sure you subscribe, make sure you hit the notification bell. Love you, crazy fuckers. See you in the next one.
Best music and video.